Hey everyone, good evening, good morning, good afternoon, depending on where you're joining us from. Good evening, good morning, good afternoon, depending on where you're joining us from. Thank you so much for taking time out for today's session. You are joining me for Insights with upGrad, the June series, and today we have with us a very interesting speaker, Dipesh, who's going to talk on a very, very interesting topic. And I'm sure all of you are really excited to get started. And he's made some really interesting slides that will be very engaging. So I hope you all enjoy this 45-minute session that is about to start in a few minutes. I would just like to know if you're able to hear me and see me. If you can, just put a hi in the chat box. Okay, great. Thanks for validating that. And a couple of quick uh, information rounds before we just start with the session, and I hand it over to Dipesh. If you have any concerns about the audio or video in between the session, just put it in the chat box. If there are questions you want Dipesh to take at the end of the session, just put it in the Q&A box. We'll be picking up a Q&A from the Q&A box, and that's all about the two main points I had for you today. Help us with your years of experience and the outcome that you're expecting from today's session so that we can customize it as much for you. Okay, there's nobody who started voting. Help us with your votes. I hope you can see the live results, Dipesh.
Yeah, I can. Yep. Yes.
Okay, so far pretty balanced. Okay. Some of you are still left. Would really request all of you to just press those buttons. There are just 2 or 3 of them. So Dipesh, we're looking at quite a balanced audience, but yeah, more under 5 years of experience today. And they're all wanting to understand more about blockchain and cryptocurrencies. Great. Thank you so much. I hand it over to you, Dipesh.
Cool. Thanks. Thank you very much. Actually, this is fantastic. I mean, the poll results are pretty cool. More than 57%, approximately 57% are 0 to 2 years, which is kind of good because I really made the entire slide deck with the objective that my audience has less clue about what blockchain is, and compared to blockchain being a technically heavy topic, you can just put on 1,000 things, and then if that were to be my audience, then this slide deck would have been entirely less meaningful for them. So thankfully, well, luck is helping me out. Okay. So I have some notes for myself, so I'm going to read the notes as well and then talk about a lot of slides. But first thing first, what I really wanted to put it out because something that's really important in the last few days, or at least the last month, me and a couple of friends were helping out with something related to COVID as Alpine. And from there, at least one experience that I have right now, that these are really, really difficult times. So everyone out here, please take care of yourselves. Try and kill the virus. I myself have not seen my family for last about 2 years odd, and I can't travel because of this virus. So please help everyone, all of us out. We really need to get this virus completely out of the planet if possible. But yeah, okay. So let's dive right into this. Okay, so we on an average or approximately we're going to talk about 9 aspects related to blockchain, but these are sort of, let's say, branches of the tree, and there'll be branches from the branches. So as we go along, you might have questions, so please note them down because I think I'll be able to address them at the end. And even while I'm talking about these branches, I might also just branch out to a completely different thing, as I might just find something really interesting and something that you should know about from a blockchain point of view. And then we'll talk about each of these, so you don't really need to read these 9 pointers right now. Okay. Before we dive into everything, a little bit of myself. I am a smart contract developer since 2019, but been into the blockchain space since 2017. 2016, 2017, I really don't have a firm time when I really got into this space. I was with PwC before I got into blockchain space. I was going into something in the financial services space and all that stuff, but nothing related to coding. So I'm a self-taught developer, self-taught coder, or whatever you can say. It's similar names, because I found blockchain as a really interesting topic. And then one fine day when I started diving in, I just couldn't stop. Currently, I do smart contract development services. Right now, I'm more or less fully employed with some company known as Enso Finance. We're going to do portfolio management services on DeFi, and I'll talk about DeFi is later. If any of you want to reach out to me, that's my website, dipeshsukhani.dev. It's outdated, but I think the LinkedIn link is correct. Maybe the others are outdated. Okay. So I want to set the platform straight, which I just mentioned a little before as well, that the entire slide deck is completely with the objective that it's going to be simple. The reason is straightforward, that this entire topic of blockchain is pretty heavy when it comes to technicals. And that makes it sound jazzy, hep, or whatever, right? But honestly, it makes it difficult for anyone to sort of then remember and then go back to your board and try to figure out, should you or should you not consider diving deeper into the concept of blockchain. So I didn't want to make it heavy and difficult for anyone to understand. So I've kept it really, really simple without taking the essence of what really blockchain is going to be. Right. Okay. So I've been talking about a lot of blockchain with a lot of my friends recently as well. One of the objective of this presentation. But what I did realize is that it was getting sort of losing the essence of why we are studying blockchain. And then it came to me that, well, let's not, why don't we first talk about Bitcoin? And essentially somewhere or the other, this is the primary reason that everybody in the world is talking about blockchain. So we thought, okay, let's just dive back into, take a step back, talk about a little bit of Bitcoin, what exactly it is and how it works. And then we go about understanding what blockchain is. And I'll try to join these dots later on in the presentation, so you don't have to worry about that. Okay, so this is where sort of becomes my home ground. Okay, so this is before 2008, 2009, pretty much near the times of financial crisis, where if you were to think about if our famous technological mythological figures, Alice and Bob, if they were to really transact into a transfer of money where Alice decides to send some money to Bob, the transaction would have happened through a bank in similar ways that it happens currently if you were to use something like Paytm, or in Singapore, we use Pay Now, these kind of services. So we basically instruct a middleman, or I should say a middle agent, to transfer money to someone else. And what really happens is that, well, there's a database involved, and there are a couple of more, sort of things involved. For example, a network of banks are involved. But what really happens is that this middle agent is actually confirming that Alice owns that $10 in my example. And then after the transaction, there will be a debit and credit, and the money will be basically transferred from Alice's account to Bob's account. That's what, let's say, pre-Bitcoin era money transfer services were. Now, there was a problem in that, which Satoshi Nakamoto, the anonymous person or a group of people, well, they did not kind of like that there's 100% reliance on a centralized database or a financial institution, which basically is controlling the entire transaction. So, famous names of Paytm or Pay Now, whatever it is, right? They just are able to A, see the entire transaction, B, confirm the entire transaction, and have the power to somewhere possibly reverse the transaction. Now, the idea of Bitcoin was loosely that can we not have a system in which where Alice sends the money to Bob directly, which means there is no third party involved at all in this entire transaction. Now, that honestly after a lot of debates, came to the conclusion it sort of is not possible because we need someone else to confirm that Alice owns that money even before she's initiating the transaction. Alice could do double spending if someone doesn't confirm that. So how it sort of came about is the Nakamoto paper, Satoshi Nakamoto's paper said that, okay, why don't we take away the middle person and replace it rather with 1,000 of middle persons. So we have nodes, what we call them. And this is what typically happens in a Bitcoin system. So in Bitcoin ledger, it's an open ledger, but sort of cryptographically secure. What really happens is that when Alice were to send a $10 or worth, or for that matter, any money to Bob, the entire network sort of comes into play or gets activated to confirm the balance that Alice owns before the money is transferred to Bob. And that's what literally is the blockchain network. This is the manner in actually really takes place in the blockchain world. Alice is required to have a wallet, which is her own cryptographically secure public key, and she needs to sign a transaction. Once the transaction is signed, it is actually broadcasted to a network of nodes, which is the blockchain network. And then that blockchain network basically confirms the transaction. And once the transaction is confirmed, the Bob, who's the recipient, literally gets that many number of coins or worth coins in $10 worth. So the idea that Bitcoin actually was intended to was to eliminate the need of a single third party and to put rather a multitude number of third parties who can basically confirm the ownership of the funds with respective parties at any given point of time. The idea was to take away this one single party who has basically n number of powers. And they can reverse the transaction, they can cancel the transaction, apart from it being expensive and time consuming as well. The only idea, as I mentioned, that I want to talk about Bitcoin is that with the enormous success of Bitcoin, a huge limelight fell upon the underlying technology, which is blockchain. And that's why everyone in the world went about saying that, okay, we need to figure out what really is or powering this entire technology of Bitcoin. Something that anyone must know is that Bitcoin did not invent blockchain or any of the related technologies, because Bitcoin uses multiple different technologies at the same point of time. It rather is a fantastic application of all of these technologies combined. It was cryptography, it is distributed ledger, as well as the blockchain consensus mechanism. Now, with that completely out of what really brought blockchain out of the boxes, I will now dive into what really blockchain is, how it functions, and what are the key aspects of the blockchain technology. Now, blockchain literally is just a chain of blocks. It is no fancy word given out of someone's whims and fancies. It's clearly just a chain of blocks. Now, each block represents a lot of data, and each of these data are sort of chronologically arranged in a particular manner, and then they are mined, or what you can say is confirmed, and then they are tied to the block preceding. And that's why it becomes a blockchain. Now, each block, as I just mentioned, has a lot of data, and each blockchain, Bitcoin being the most famous one, there's Ethereum and a couple of more, define what a block is supposed to have and in what manner each of this data has to be hashed. In Bitcoin's case, it has the transactions, which let me see if I can get my mouse over there. Yeah. Okay. We have a lot of transactions. Now, this is the first block, so it never has a hash to begin with, but the hash of the previous block actually goes into the next block. This proof of work, which is something known as nonce, and I'll sort of talk about it in a while. But all of this is basically the structure of the block. And there are a couple of more things like your timestamp, your state root, and some more things. But technically, again, this will be too much to get into, so I'm not going to dive really into every aspect of what a block has. But more or less, you can simply put these are transactions which a miner, and when I say miner, literally a software, takes and confirms and then calculates the proof of work or the nonce. In Bitcoin's case, what really happens is that there's a hashing algorithm, and the Bitcoin algorithm itself provides something which what we call is a difficulty index, which let's say is a random number of 245. The hashing algorithms or the Bitcoin's algorithm, which anyone would run, the idea is that when you confirm the transactions, you need to calculate the nonce. And that is what your proof of work is. Basically, you're running the software for a long time, trying to guess the work or guess the nonce, which can then confirm all the transactions and put it to the blockchain. The features, the key features of any blockchain are one of them is immutable. So just dive right back into the slide because that's important. Once a block is mined, which let's say, for example, in this case, block 2 is mined, the hash of this goes to the next block, which is block 3, and similar, and it keeps on going. What really, if you can think about, is that if any of this were to suddenly change this transaction, then the hash will change. Now, hashing in the most simplest way is nothing but a formula which takes a certain number of inputs or any amount of input, in fact, and then just hashes and generates a number out of it. And that's what it is. So even a single change of a character, for example, a capital A becomes a small letter A, the hash completely changes. So the block 3 hash will completely change if someone were to say that transaction 4 is not what the blockchain says, but rather it's a different thing. For example, Alice says that transaction 4 of me sending $10 to Bob is a lie. I mean, I never sent it. That sort of is not possible because it's mined in the blockchain. It's now on block 7 or block 8, which means Bob need not worry that anyone can tell that, well, you're not supposed to receive the money. So that's what is the most important feature of a blockchain. It's completely immutable. Let me just go there. Second is cryptography. Now, think of blockchain as something like an open ledger. Now, if you just walk down the open ledger path, what's going to happen is that everyone in the world would possibly know who owns how many Bitcoins, or for that matter, any other coin, and what are the assets. In the Ethereum cases, you can have multiple assets on the same blockchain. That's something was solved by using cryptography. So the account that I have on Bitcoin or Ethereum is nothing but a number and some few characters. The account that you will go and get if you open a wallet will be quite similar, just a hex string of numbers and characters. Each of these are operated through something what we call as a private key. Again, something which are just characters. Through an outside world, no one knows who's behind those public key and private key pair. And really what really happens is that when I confirm a transaction to a friend of mine, I will send a transaction link or a transaction hash. All they can see is that it has come from A account and they have received it into their receiving account. Bitcoin and some other blockchains work in a different fashion. In Ethereum, they will be able to then forever know that this is my address. But in Bitcoin, that's not possible as well. The point that I must also let you know over here that in Ethereum itself, I can have multiple accounts. So it really doesn't matter to me if someone is able to track my account for once, because I can have multiple accounts and sort of have my assets stored differently in different accounts. So what really happens is that for the outside world, you just have certain characters, but only you know how much you own. And if you want to prove it to the world, you can sign a transaction, just prove that I am the owner of so-and-so account. Third, it's decentralized. Now, actually, I'm following a little bit of chronology over here. The first two are sort of really important or must-haves to a blockchain. The third and the fourth one, which I have next one, are sort of good to have. The reason I say good to have is because there are certain blockchains who do not somewhere respect these features. Decentralized over here means that you have multiple number of nodes and not a single party, or in fact a consortium of parties, are able to control the nodes. So these nodes just function independently. In the case of Ethereum today, there are approximately 10,000 nodes that are live around the globe. With that, what we have is that you really do not have, or for that matter, no computing power today exists that can actually stop Ethereum from functioning. And similarly, Bitcoin. There are just n number of nodes completely distributed around the globe. To bring down that number of nodes at a single point of time sort of is impossible. So that's the third feature. The reason why I say it somewhere is not respected is that for newer blockchains that come up, you really don't find people simply downloading their software and really running the nodes. And really what happens is that sometimes it's that single corporate entity which just sort of runs the show. So they download the blockchain nodes and then just run. So they're controlling the majority of the nodes with respect that they don't want to cut it down. Fourth is a consensus mechanism. Now this one is basically the mechanism that the software lays down in which all of these nodes will talk to each other and agree which transaction was first and which transaction was last and how to confirm a transaction. So that's about it in terms of the blockchain. It's really nothing but a chain of blocks, has all the data stored in a particular manner, cryptographically secured. It should be decentralized and should be permissionless, which means anyone should have the authority to download the software and run the node. And that's why I wanted everyone to sort of take a little bit of a small break to sort of just gather thoughts around and figure out, okay, this is what blockchain is about, because it can just get a little more deeper from here. Okay, the second, the topic, as it says, is introduction to blockchain and cryptocurrency. So that's the second aspect of today's presentation. Now, question that I have for you, and while it's a poll question, but you can just sort of have the answer to yourself, and then we can, if you want, we can talk about it later, is that can a blockchain exist without a cryptocurrency? I'll run you through what cryptocurrency is, and then we'll talk about how it sort of comes into place, and then whether a blockchain can or cannot exist without cryptocurrency. Now, cryptocurrency is simply put just an electronic cash, electronic representation of points, which are transferred from A account to B account. Again, the Bitcoin example that I gave. The features that get added is that it has to be secured by a cryptographic algorithm, which means that no one should be able to control the private key. It's only a one-way transaction. Second, it is secured by a complete big network. And that's why it's called cryptocurrency, because of the cryptography involved in this virtual money. The birth of cryptocurrency actually comes from the very simple reason of running a blockchain node. In simply put, when Bitcoin, Ethereum nodes someone runs, you're running a lot of resources. You're investing in a lot of resources. You're putting your computing power to sort of determine, the longest chain and run the entire blockchain. That resources are sort of rewarded by something what we call is mining. In the most simplest way, if I download the Bitcoin node right now and run it, I am a miner. If I confirm the transactions, I'm a miner. And since I'm doing this hard work, basically my computer is doing this hard work, I'm going to be rewarded by the Bitcoin blockchain in the form of cryptocurrency. And that's why literally cryptocurrency comes out of the system, or sort of takes birth. Once I have them, then I transfer them, and then they are sort of tradable or transferable between anyone in the world. And that's where literally Bitcoin or any other coin takes birth. Now, that's all about blockchains and cryptocurrencies. I have more slides about entire, more stuff on blockchain related world, but I wanted to sort of give a heads up that from on there are these a little more technically deep topics. So kind of be prepared for that. And to answer the question that I raised before, there can be blockchains without cryptocurrency. One classic example of this is Hyperledger. Now, it's a private blockchain that companies run or consortium of companies run to do certain transactions among themselves. And these blockchains do not have the need of cryptocurrency. Only public blockchains somewhere use cryptocurrencies. That's mostly to be able to defend spam attacks, for you to do any transactions onto the blockchain and just completely block the blockchain. So to do a transaction, you must pay a fee, and that is payable in that cryptocurrency, and that is valued. Okay, so I'm going to jump into a critical aspect of blockchain, consensus mechanism. The primary reason I'm going to talk about it, I want to talk about this, is because it's really a hot topic these days. I don't know if you've been following up, but a few days back, Elon Musk went ahead and said that they do not want to accept Bitcoin because of its environmental impact. And then he recently apparently changed the stand yesterday, saying that if somewhere Bitcoin were to use energy efficient systems, then Tesla might go ahead and continue to accept Bitcoin. And the entire talk about energy efficiency actually relates to consensus mechanism. Just a minute, I don't know what really happened. See a black screen. There you go. Okay. And before we dive into consensus mechanism as to what that hot topic is related to, I just want to tell you where that entire consensus mechanism root problem exists. In every transaction that happens on a Bitcoin network or a Ethereum network, what really happens is a technical term, which we call the mempool or the memory pool, exists. Example, if Alice were to transfer $10 worth of Bitcoin to Bob, transaction first sits into something known as an unconfirmed pool of transaction, something known as a mempool. Basically, these are all transactions that are sitting and are waiting for miners or the nodes to pick up, hash them, confirm the hash, and just add it to the blockchain. Now, that consensus mechanism is where once a particular node were to confirm a transaction, then how does it relay that information to all the other nodes in the network? A classic consensus mechanism would have been that the node would have relayed the information to every single node onto the network. But that would be time consuming and really would have just killed the blockchain with its amount of confirmation, the amount of time it would take to confirm. So something what was proposed by Satoshi Nakamoto was the proof of work, which means that the software, the Bitcoin software, will sort of confirm that yes, this transaction is okay to be added to the blockchain once it meets once the proof of work, or basically the mining activity, or again, technically put the nonce of the transaction matches the nonce that is expected. If that is to be done, then the Bitcoin blockchain will just accept the block. And really what happens is that all the other nodes are informed that the Bitcoin blockchain has just added a new block, and you must confirm the balance transactions to add to the another block. So block 4 is done, please work on block 5. Block 5 is done, please work on block 6. This proof of work is sort of the most contentious issue of Bitcoin blockchain. Proof of work requires n number of nodes to process and confirm n number of transactions, many times being the same transaction being confirmed by the same number of nodes across the globe. This eats up a lot of resources, electricity, as well as your computing power. Now, Bitcoin blockchain is sort of completely decentralized and democratic. Essentially, no one can get up and change the code of the Bitcoin in itself. And hence the proof of work will sort of continue with Bitcoin forever. And that in itself is causing a huge impact on the environment. The next one that is proposed by various other blockchains and in fact used already by a few of them, is something known as a proof of stake. In proof of stake, what really happens is that rather than every single node running into a race of confirming transactions and being able to mine the block for the block rewards, it is completely, the mempool is divided into smaller lots and distributed across nodes. And the respective nodes are then only responsible for confirming those transactions. So we are helping out, taking out the duplicacy in multiple nodes fighting for the same transaction. The stake version over here is that not me, not you can participate in the confirming transaction process, but only those nodes which are able to put a capital outlay can confirm the transaction. And that's why it's known as your staking mechanism. The idea is that if I were to do a wrong judgment call, or basically confirm a transaction that should not have been confirmed, then I will lose a portion of my stake. I will be penalized by the blockchain. This is the simplest way of presenting the proof of stake. There are, again, issues associated with them, and something that the Ethereum or the other community blockchain wants to adopt is something known as a delegated proof of stake. But there'll be too much of technical, so I don't want to really dive. But that's how somewhere the blockchains like Cardano and Ethereum are wanting to go, so that they can actually be more environment friendly. I'm going to talk about the biggest blockchains that currently exist and their subtle differences. Bitcoin, I've been talking about probably from slide 2 to 3. The second biggest blockchain being Ethereum. Third being the Binance Smart Chain. Now, Bitcoin and Ethereum are really famous. I really don't want to talk much about them. I'll just give you a quick introduction for all the other three. Binance Smart Chain is today the third biggest blockchain in terms of market capitalization. And it's very, very similar to Ethereum. The only difference that is between a Binance Smart Chain and Ethereum is that Ethereum is proof of work. Binance Smart Chain is proof of authority, which means I cannot run a node and confirm the transactions. I need to be authorized by the pool itself that I have the power to confirm the transactions. It is not even a proof of stake. It is just a proof of authority. They can literally give me the power to confirm or not confirm. Cardano is a proof of stake blockchain. The difference between Cardano as of now and Ethereum, being this other second biggest blockchain, is that Cardano as of now doesn't have the implementation of smart contract. I'll come to what smart contract is in a few slides. Doge and Ripple are similar to Bitcoin in terms of how they function. Doge is quite very similar to Bitcoin, completely democratic. Anyone can run the node. Ripple, on the other hand, or XRP, is a permissioned blockchain. And that's why one of the features that I've mentioned that a blockchain should respect is permissionless. Ripple is not permissionless, which means I can only run a reader node. I will not have the authority to just confirm the transactions. Ripple, as the organization stands, will have to give me the authority to confirm the transactions. And that's why Ripple is somewhere considered more controller-friendly blockchain. And that's why banks and financial institutions have been preferring to work with Ripple blockchain versus a Bitcoin blockchain, because they want to see who's running the nodes and what power does that person has. Now, these are the key bottlenecks when it comes to Ethereum blockchain. Somewhere I'm focusing on Ethereum because I am more an Ethereum developer versus others, and Ethereum currently is, in my words, the most biggest important blockchain that someone should be focusing on. Bitcoin doesn't have one feature, which is the smart contract feature, which Ethereum has, because of which there is X number of possibilities that arise when it comes to using an Ethereum blockchain. Ethereum blockchain currently functions at a transaction per second speed of 13 to 20 on an average, which is very, very, very low compared to the target that it itself wants to achieve. Somewhere they want to see that can Ethereum really be competing with the networks of Visa and MasterCard, which really process somewhere around 1 million transactions plus over a second. Second feature, which is really right now harming Ethereum, is the transaction fee. Now that's the fee that is payable in the cryptocurrency, which is in the Ethereum case, Ether, that I must pay to actually process a transaction. So a transaction of Alice and Bob, Alice must pay a transaction fee to the miners to be able to read the transaction and confirm the transaction. The reason why it is harming is that with the current prices of Ethereum and other cryptocurrencies, confirming or paying miners to confirm a transaction is a very expensive deal, sometimes not even worth it. And that's why that is somewhere asking people to shift from the Ethereum blockchain. Third being the proof of work, which is the consensus mechanism. This again is from an environment point of view, that it's using up a lot of resources to run the blockchain. Fourth is hard fork. And when I've written versus Tezos is a blockchain which doesn't have this issue, is that if the Ethereum blockchain were to update itself, there's always a risk that a blockchain might just fork itself and a second blockchain might come to existence. In the case of Ethereum, it actually already has been done in the past when there was a hack in 2018, if I'm not wrong, where the Bitcoin network had to upgrade itself or sort of fork to prevent that hack to happen, sort of for the hacker to run away with the money. And what came out was that there's something known as an Ethereum Classic. Now, Ethereum Classic is because the miners who run that node decided not to kill that blockchain and rather continue with it forever. That is the Ethereum Classic. And what you see Ethereum today is actually just the version 2 of the original Ethereum. Most of the problems that I just spoke about are being somewhere solved by something we call as layer 2, loosely known as sidechains. There's a subtle difference between these two, but we'll not dive into them. These are the famous ones which are currently being used up a lot or sort of are in the news: Polygon, Loopring, Optimistic, and Arbitrum Rollup. Now, how somewhere they solve the problem is that all of these are actually just, in simple sense, running completely different blockchain. And that's why we call them a side chain. The difference them versus any other blockchain for that matter, Cardano, will be that they have their root stored back onto the Ethereum main chain. We call the main net or layer 1. And really, that's why we call them, okay, these are side chains. And you can do a lot of these transactions that you do currently on the mainnet. On the side chain, they have smart contract capabilities as well. But that what you're doing is that you're actually securing the entire blockchain itself by putting everything, the root of all the transactions, onto the main chain, the Ethereum blockchain. Now, somewhere as a developer, where if I were to trust Ethereum blockchain, I have the same trust on these sidechains because I know for a fact that if I've been trusting the decentralization part of Ethereum, the distributed network that Ethereum exists with, then I do not have to worry about these sidechains because my root of the transaction is stored on a different node. The benefit of running these sidechains or actually doing any of the transactions on these sidechains are, A, they are very, very cheap, somewhere claiming 99% cheaper to doing a transaction on Ethereum, for a reason that their native token itself is not that expensive, as well as their requirements to pay a miner is low compared to what Ethereum is. And second being that they are very fast. Ethereum talks about 14 seconds to confirm a block. And these, on the other hand, can take about 2 to 3 seconds, as well as the block size for these blockchains is way more compared to the block size of Ethereum. And that's the key difference, that because of which these blockchains are running at a fastest level. And these are some of the most famous uses of blockchain in the real world. And that's why blockchain is just not a concept that can stay in the air. It's going to sort of impact us more on a day-to-day life. In international payments, you've already heard there's Ripple, which financial institutions use for transferring money between themselves. Now, Ripple is primarily a competitor for Swift, so that's what they are, and that's why it's one of the most famous uses. Exchanges run their entire settlement on different ledgers, and there's an exchange based in Singapore, one exchange, which actually uses blockchain in its backend. And what really happens is that taking away the need for different parties, a custodian as well as a banker, to come and confirm a transaction by putting everything on the blockchain. There's an entity based in, if I'm not wrong, the Africas, Propi, which is actually taking the entire real estate registry and putting onto the blockchain. Again, taking out the need to going to a centralized government body to confirm who owns how much of land. Civic started out of South Africa, 2017 onwards, is trying to put the identity of everyone onto the blockchain with the objective of ultimately at some point of time taking away the need of having passports being issued by a country, but rather having everyone's identity put onto the blockchain. Social media, similar to Reddit, there's an application which we call Steam or Steemit. They pretty much function like Reddit, but what they do is every interaction with the platform Steam actually somewhere pays you as a content provider. Now, the idea is very simple. Every platform like your YouTube, Instagram, they earn fee from advertisement, so does Steam. But in the case of YouTube and Instagram, it's the entity which is responsible for how much the amount must be shared with you as the content creator. But in the case of Steam, it's sort of put everything on the blockchain. So any likes, I mean, I'm just calling them likes, but they're upvotes, literally turns into a cryptocurrency, which is immediately put into my wallet. And I will, based on the rules of the blockchain, will be able to withdraw them and then put to use. Another use case is of Blood Diamond, where Everledger literally puts the transaction history of the diamonds, where they're mined from, which entity, and what processes were adopted to mine those diamonds. And the idea is that people who are consumers of diamonds will possibly not want to be engaging themselves with diamonds which are not mined morally in the correct fashion. And Blood Diamond is literally that concept. And Everledger wants to just put that information outside. Now, the future of blockchain is something that is sort of very wide, and somewhere the word sky is the limit really applies to this one, because we really don't know what things are going to come up in the future. Everyone's playing with a lot of applications every single day. New applications come out on blockchain, and it's really difficult to judge. But I'll talk about a few cases that exist today somewhere, and some are in sort of workings. And you can then see that it has sort of an immense, really bright future actually. DeFi is basically a short form for decentralized finance. And I've been working in the DeFi space since 2019, somewhere when the DeFi concept was born out of. Essentially, in DeFi, what really happens is that we're taking the financial world and the idea behind all the transactions that happen on the financial world and putting onto smart contracts. Smart contracts are nothing but a piece of code that gets executed whenever a function is triggered onto the blockchain. Currently, what exists is that there are lending and borrowing of cryptocurrency assets with smart contracts that exists today, and that has been in existence since about 2019, picked up really highly since 2020. There are exchanges which exist. The difference between a decentralized exchange and a regular exchange is that you don't have an order book, and what you're always dealing with is a smart contract. There are synthetic assets that are coming to play. There's gold and the currencies, and there is a synthetic Apple, the synthetic Google share, everything on the blockchain, which is nothing but a mirror of what these assets are or what the prices of these assets are on the real world. They're reflected into the blockchain world, and then trading happens in those. Something that I have been working with a few people is physical asset collateralized loans, which do not exist today in blockchain, is that people will be able to lend or borrow for transactions that are related to actual assets, or for example, home or car, where the the asset is collateralized into the blockchain through a particular mechanism. The mechanism will be somewhere close to IoT, where the key of the transaction, or sort of the key of the device, is securely stored on the blockchain. Social funds are being thought about to put on the blockchain. And these are community projects, for example, UNICEF or UNESCO, where they actually come out with projects and they come out with a budget that needs to be spent to meeting the objectives of the project. Those transactions are currently controlled by a centralized authority, being the organizer itself. The idea is that can we move all these transactions onto the blockchain, where if the funds are being spent, then the other parties also onto the open ledger. And then what we're bringing is transparency to the entire project spending. On this, the last idea is something that someone coined about a few days back. No one's actually implemented is that can we put all the vaccination related information in the case of COVID onto the blockchain? The idea is that if someone to be vaccinated in a particular country, then that information is now available publicly onto the blockchain and for anyone to access in the world. So really you don't have to carry on the certificates flying around into different countries showing that I did take a vaccination or not. And also somewhere we take away the trusting mechanism of an organization that should you trust a certificate or should you not. Okay, how to get involved in blockchain? There are multiple ways, but I'll focus something related to developers. Now, Bitcoin doesn't have this. What I mentioned before is something known as smart contract, but Ethereum has that. And as I mentioned before, smart contracts are nothing but a piece of code that gets executed based on a function that is triggered. Sometimes these are automated, or sometimes these are manually triggered from outside the blockchain. Now, what really happens in the case of a smart contract related application is that you have a very simple application, something like a Facebook or a Twitter, any other website you can think of. Front end looks exactly the same, but in the back end, what really happens is that the transactions are stored onto the blockchain, and the transactions, if they need to trigger any particular action, those actions are stored onto something what we call as a smart contract. Smart contract development in itself is a huge and a different field altogether. The most famous language that we use for developing smart contracts is Solidity, and there are a few more, but Solidity is one of the sort of most used in the case of Ethereum, and that's where the entire sort of career aspect lies into. Other than these, anyone can actually get involved in blockchain just by running a node also. You can run the nodes. It's a little expensive to run the nodes, but it's still possible. On a high level, I just wanted to put this out. A Web3 developer, what we call it, is nothing but a person who has a skill set to be connect your applications to the blockchain world. That in itself is a completely separate industry. The primarily important languages that we use over there is Ethers.js and Web3.js. The skill needed, or you must know before diving into Ethers.js or Web3.js, is JavaScript. So if you're a JavaScript developer, then learning either of these will be simple and easy. You can become a smart contract developer, and smart contract development can be done in multiple languages, Solidity being the prominent one. You can write smart contracts in Node.js, Java, and Rust. Rust is a new language, so not such heavy resources available over there. An average salary of a Solidity developer today is revolving around 150,000 annum. And there's huge demand for smart contract developers in hot markets like US, Singapore, London, Germany. But the biggest of all of them is remote. I am a smart contract developer, really functioning remotely. And there's a very big smart contract developer market in India. And more or less everyone functions over there for companies outside of India. That is it from my side. Mehta, I think you want to jump into this one?
I will very quickly wrap up because we've got less time for question and answers. Thank you so much, Dipesh. It was a very, very detailed session, and I hope all the people listening today know a lot more than they came in with. And just talking about who we are as upGrad and what does upGrad learning experience entail. We've got amazing speakers like Dipesh who are a part of our live instructors and our industry mentors who take the live sessions, who take small coachings, and do take one-to-one career mentorship for those who want to excel and build a career in technologies like blockchain. We can move to the next slide. We've got programs being offered in data science, technology, machine learning, and different programs for different people who are wanting to engage with, say, certifications or have executive programs or masters in these technologies. And the great advantages is that one, you get to interact and network with people from 85 plus countries, and two, you get to have an alumni status while you're working. So upGrad tries and provides courses for people who are working professionals and don't have to drop off from their jobs to be able to pursue these courses. And three, you're getting 360-degree career assistance in the form of mentors and mock interviews to be able to propel into that career transition or into the career you're currently in. So that is who we are as upGrad, and thank you, Dipesh, once again for a very beautiful session. We will move on to the Q&A now, and we can pick up questions. I think you're able to see it on
right.
in the window.
Right. This is this. Okay. How is encryption done? What is the okay? I'm going to try through the questions as they come along. How is encryption done? What is the role of blockchain? How can we be sure that the transaction is not hacked by any hacker? Right. Okay. Encryption done on different blockchains is through different algorithms. The most famous one is SHA-256, SHA-256, or we call it. Now, so these are different algorithms. These are public algorithms. You can open source. You can download them, run through them, study them. That's available any case. The role, what is the role of blockchain? How can we be sure that transaction is not hacked by any hacker? Right. In the most simplest way, to hack a particular transaction, what I would mean is that I will go to a transaction that has occurred in the past, a confirmed transaction, and change the transaction. That's what my motive would be. Right. Okay, that question disappeared. But to do that, I will have to hack into more than 51% of the nodes that exist, which will mean, in the case of Bitcoin, Ethereum, hacking into more than 5,000 to 6,000 nodes at any given point of time. That's why it's really difficult to hack into a blockchain and change a nature of a transaction that has happened in the past. Okay. What is the difference between, sorry, you're saying something?
Yeah, I can see David asking why any chance is one exchange related to 1inch?
They are not. They're not. One Exchange is a private organization. 1inch is a decentralized application.
That's cool. We can go back to the Subarna's question, which is what's the difference between proof of work and proof of stake? I think you've already explained it in your presentation.
Right.
So we can, Subarna, you can go through we'll be sending you the recording link of the session. You can go through it again.
Okay. We have lots of blockchain platform, Coda, what would we suggest? Some work in the banking domain, not who's a market leader in black. Okay. Right. Hyperledger, if I have to give you one word. Hyperledger Fabric.
Cool. And Samir, we may have another session on Hyperledger if you're more interested. And we also have it as a part of our program.
Decode something by cryptography. Can we decode? No. Let's put it this way. Simple answer, no. We cannot decode something cryptography concept. Yeah. I mean, Yeah, no is the straight answer. Do we have any chance? Do we have any chance to get into blockchain in India? There is multiple, I mean, n number of opportunities that exist. Huge number of opportunities. You just have, yeah, that is huge. That's what it is.
Well, I think you could take some of the examples that Dipesh talked about in his, I think, second last slide that he was talking about, and definitely go ahead and search a few names of firms who are currently hiring in this domain.
Yeah. Polygon Matic, the one that I mentioned layer 2, is a very big project. It's based out of Bangalore. Very big project. It's true that blockchain has limited when it comes to real-time systems like real-time cycle pending apples. No, it's not. It depends on the nature of the blockchain. Samir and its question in terms of the limitation. No, it depends on the nature of blockchain. Bitcoin and Ethereum have a transaction time. You can design a blockchain that doesn't. Or if one wants to become a smartphone developer, learning Solidity is a completely learning programming expert. JavaScript for Solidity, I would say, is a sort of a must. Yes, JavaScript. Let's put it this way for Solidity. Which banks in India or abroad are currently live on smart contract and what instead? Okay. I would say Mukesh's question on public blockchain, none that I am aware of on a public blockchain, because I think regulatory reasons, none of them that I'm aware of have done a transaction of public blockchain. I will not be surprised if they have dipped their toes and done a transaction on public blockchains, but they haven't made it public. So obviously they are not of huge, enormous volumes, like millions of dollars like that.
Okay, the question was which banks in India are currently on?
Yeah. Of all blockchain, so now I'm going to ST's question. Of all blockchain examples you have worked on so far, like Ethereum, right? What has trajectory been like during these growth times? Have they all done well? Actually, no impact at all. Honestly, blockchain has never had any impact related to COVID. Okay, please, if one wants to be a smart contract, I think I answered this one. David's question. So that's JavaScript, I would say.
Got it.
Yeah. Is there any blockchain running on plastic recycling? Unfortunately, this is a hybrid situation. Blockchain doesn't have to do anything with physical world, you can say. So someone must come up with the entire plastic recycling, then what needs to be put onto the blockchain. But blockchain really can't do anything. It's just a software.
I don't know. Do NFTs have to do something here?
No. You can issue an NFT, but NFT is again just a piece of code, right? So you can issue an NFT to someone who has done X or Y things, for example, plastic recycling. But really, blockchain has nothing to do with recycling. Yeah.
Got it.
Of all the blockchain examples, okay, I think this is answered. No, wait, no. Yeah, okay, I see that one. No, so anonymous attendee, no problem.
Yeah, we've already done that. Wow, the person has asked the same question quite sometimes. Okay, another question, which is usually blockchain is hiring on experienced candidates.
Isn't it something very rare? How can you get this one? Right. Okay. I don't know how to answer this. The point is, if you can write smart contracts, I'm talking really about Ethereum case over here. You can write smart contracts, you can put it up onto the blockchain, deploy it, people, and there are forums, just put them onto the forum. This is what my smart contract does. If people find it useful, they use it. If they use it, they like it, they'll continue to just, there'll be entities which will be ready to hire you. So it's really that simple. You really don't need certifications or anything like that. No one in blockchain world somewhere hires based on smart certification. I have practically no certifications.
I mean, certifications are just a way for you to have things served on a plate, right? I mean, you have, say, modules just arranged and you're using a very methodological format of learning it. While you know that there could be, once you start exploring it, it could be a whole ocean out there.
Absolutely.
Certification just helps you do it in a much structured format.
That's correct. Yeah. What is the role of banks in blockchain? When the genesis of the blockchain was to eliminate these, right? Multiple banks are working, mostly in cross-border transactions. The idea is again to take away the network of banks and make it more streamlined. Ripple actually helps that. And trade finance, where again banks are or participate into the entire trade finance, whatever chain. So they want to take away the need of relying on multiple parties, and that's how they're using the blockchain. Somewhere they don't like it, but they want to use it. All right. Okay. Should I just dive really into the balance question? There are 3 or 4. How is it? Can I just answer the balance questions?
Yeah, we can. I just launched the poll because we're at the end of the time. And for those who have been with us so far, thank you for staying with us for the session, and request you for your feedback while we still have a few questions that they should be answering. I've just launched the poll.
Okay. There's a lot happening in the field of trade finance using blockchain. Correct. Similar to what I just mentioned. What's really happening in that space? Yeah, they're all using private blockchains for doing trade financing, transaction monitoring onto the blockchain, but not public blockchains. How is XRP currently progressing? An alternative, very strong, except XRP unfortunately is facing a legal battle, fighting a legal battle in the US, and that's why it's a little bit of a bumpy ride for them. But they are a very strong competitor to Swift. Swift in itself, by the way, has started using blockchain, so they're really going to have a fight. For circular economy substantial, can blockchain support? I actually don't understand this question. That disappeared. But, yeah.
I think David's question is interesting.
Where do you see blockchain 10 years time? Do you feel the same way it will be accepted worldwide and in the same ways that anyone can reach out to you? Right. Okay. So 10 years time, Bitcoin has been there for more than 10 years. And with the same ideology, various blockchains will continue for a really, really long time. The need for centralized third parties will continue to die by putting things onto blockchain. Blockchains are not economic, environment friendly and efficient enough right now. So that's a very big research area. And with that, once sorted, it's just a huge, huge future for blockchain itself. And is there any way someone can reach out to you? Yes, I think upGrad. I think you should reach out to upGrad, and then and my website link is there in one of the slides.
Great. That brings us to the end of the questions that we had. Great, very effective use of time in that way.
I didn't expect I would. Yeah, sorry, and I was a little nervous. Yeah.
No, it was really informative, Dipesh. I hope everybody agrees with that. Whoever's on the call so far with us. Request all of you to fill in the feedback form that I've shared with you already. If there's any way you would like to reach us, just write to admissions@upgrad.com, or you can block some time here on this Calendly link with us so that our admissions counselors can reach out to you and help you create a plan around, how do you want to go about choosing a program with us. And if there's any questions you have about, hey, how can I actually manage learning along with my work? Because it seems absolutely impossible to do that together, but we'll definitely help you with a plan. And do visit our website for other courses that may interest you. And thank you so much, Dipesh, once again for this session. We will continue to reach out to you as well for more such interesting sessions.
Thank you.
Thank you, everyone. Have a good evening.
Bye-bye.